And did we get one more? No, just 3? No Gina, no Andre, no Angel? All right. Well, maybe they'll come in a minute. We got to get started. Good afternoon, everybody. As you may have heard, I've got sound going. I have directly connected the computer straight to the speaker via Bluetooth. So now I can hear you on Zoom if you want to ask questions out loud. Aha, Angel has arrived. Very good. But I still have no projector connectivity there. So you guys in person, if you want to see what's going on, and you probably do, this is geometry, it's a very visual math, you will need to also join the Zoom call. Okay, with that said then, let us get to it, and we will start with reviewing the answers from yesterday's work. That was to 5. So here are all of the resulting angle measures. Most of those pretty straightforward. I'd say, if anything, 5 might have been tricksy with the overlapping right angles. It was maybe a little tough to tell if you didn't have a digital copy to zoom in on. So that's those guys. Then 7 through 10, you had to decide just how true these statements were. Are they always true, but only sometimes, or never? And the best way to determine this, or one technique, I suppose, maybe not the best, is to think about actually how can I make this false? Think of the opposite. Can you always make it false? It's like, wait, this never actually happens. I can't think of a single example that makes it true. Can you think of one example that shows it's false? Like, right? One counterexample, but there's also an example where it is true. So if you can think of one of each, then it's a sometimes true. And if you can't think of a time that it can ever not happen, something in the definition, well, if it's 90 degrees, well, then it's certainly at least 80. That 90 is more than 80, right? So that would always be true. Okay. So then that's those ones there. And then the final set, 11 through 15, fill in the blank. Nothing much to add there, pretty definitional for those guys. Okay, any questions then from yesterday's work? No? Okay, then for today we are diving into the parallel lines, which we covered the conjectures yesterday. So if you haven't filled out that part of your notes, make sure you go back to yesterday's video and do that. Today we will do some practice with those here. And well, before I get to that, right, these kinds of questions. So the same as those first ones with finding the missing angles from this diagram. The SAT loves these guys. And in fact, the more complicated, the better, as far as the SAT is concerned. So I would pay especially close attention to these last few. Number 7, look at all that business going on there. But you can handle it. Break it down, one thing at a time. In fact, one tip I would offer is don't focus solely on the lettered angles there. Fill in anything you can figure out. Go ahead and write it down. And that might help you on your way towards solving one you're actually looking for. And then when you get to 8 and 9, they like to make things more complicated. Hey, you know that geometry thing that was really simple? What if we made it more complicated by just throwing extra algebra on top of it? They do that all the time. It's kind of annoying. I fully admit that, and I will agree with you. But is it realistic? Yes and no. Maybe not quite to the extent that they often display here. Like these having no real idea of what these values are or how they connect. But sometimes you do know more about how one measurement relates to another than you do about the actual measurement itself. And so you might start with that unknown. I don't know this measure, but I know it's 30 more degrees than that one, because you've compared them, but you haven't measured outright from scratch. That can happen. But I'd like to make this easier before we dive in. There's a simple shortcut that we can use that takes all those conjectures from yesterday and condenses it down, because there's so many patterns going on, so much consistency across these angles, that you find all of the numbers end up repeating themselves, right? I know that these two in blue here are vertical angles. They will always be congruent. And I know this one is, there's my backwards z, so alternate interior angles with this blue one. And then vertical angles, it's congruent to that blue one. All of these will always be congruent to each other. You will use these specific conjectures to justify why one is congruent to another. Okay, so for any specific instance, you have to explain why you know, or how you know, or justify your answer. Use the conjectures. But if you're on the SAT, and all you care about is, I just need to get the answer as quick and easy as possible, then notice this. Turns out there's only ever 2 measurements on the whole diagram. In a setup such as this, with just the parallel lines and the transversal, there's only 2 numbers, the acute angle measurement and the obtuse angle measurement. All the acute angles are congruent to each other, and all the obtuse angles are congruent to each other. And if you're really lucky, it's actually a perpendicular event, and then they're all 90 degrees, and it's even simpler than that. And as a result of this, we can go one step further and say any combination of one of each, one acute and one obtuse, no matter which one you're grabbing from, whether they are a linear pair or not, any combination is supplementary. Okay, so I can take the 2 on the inside here, the consecutive interior angles, those will be supplementary. I could take one out here and one out here. I guess it's not consecutive, but like same side exterior angles, also supplementary, right? Any of those, because there's only the 2 numbers. And those 2 numbers will always add up to 180 degrees, right? So this handy shortcut lets us answer questions up here really fast. Let's do one example together. And then we're going to do a quiz. We'll switch to a quiz, get you some live feedback practice, and then you'll have the rest of the time to finish these exercises. Okay? So take a look at number 1. Here we've got to find 3 of these angles here. This is given as 54 degrees. So first classify the given one as acute or obtuse. What do you think it is? This 54-degree angle, is that acute or obtuse? Are you on the Zoom call? Why is it not? I have not had visual this whole time and nobody stopped me. Why didn't you say anything? Is that better? So you guys just sat there looking at a blank page? Like, I don't know what he's talking about. It sounds good, sure. Oh, good help is so hard to find these days. All right, the short version. Back here. Here we go. Visual statement. Lock this in your mind. Parallel lines. All the acute angles are congruent. All the obtuse angles are congruent. Okay? Color-coded them for your convenience. They match each other. Okay? You can go back to the, well, I guess you're going to have to go through the YouTube channel and link to one of the other classes because apparently I wasn't even broadcasting those parts. This is what you get for not speaking up. All right? More work to check your answers. Anyways, so all the acute angles are congruent. This 54 degrees is acute angle. So we could just run through this and label every single acute angle you see. This is acute. This one, acute. 54 degrees. This one, acute. 54 degrees. This one, acute. 54 degrees. And that's everything they asked for, right? Boom, boom, boom. All the acute angles are one measure. If they asked for one of the obtuses, all right, there's the obtuse one. 180 minus 54, just do a quick subtraction. 180 minus 50 would have been 30, but we subtracted 4 extra, so take 30 off of that. 26 plus the 100, so 126 there. 126 here, 126 here, 126 there. Just, they fill in automatically, okay? That would be my recommendation to you, is just populate the whole diagram with as much as possible, okay? Unless you get to a point where you've got too many things written in it and it becomes cluttered, okay? But those are the only two numbers you need with parallel lines. Some of these will be a little bit fancier, and they'll start incorporating other lines and segments into them, in which case you will need to draw in from the other conjectures. Okay? Any questions then? No? All right, then prepare for a quiz about these such angle relationships. Here we go. Go to joinmyquiz.com. Enter the code 785941. That's 785941. Got 4 in. I need more. That's 5. And 1 more minute to join the live quizzes. Oh, is that it? Oh, there we go. I mean, if you don't join now, you're just going to have to do it later. All right, let's begin. Oh gosh, that's too loud. Hey, way to start us off with 100%. Nicely done. doing? 75, 76? It's a good start. Keep going. Remember, you can use your notes. Use some scratch paper and write things down if you have to. Use a calculator if you have to. All right, when you are finished with the quizzes, go ahead and work on today's practice exercises and get started on those. And we've still got, let's see, till 1:40. We've got another 20 minutes to work. So if you're still on the quizzes, keep working. If you're done with that, go ahead and switch to today's problem set. Now, one of the nice things about the quiz is that when you're done, you can review your questions and answers and see what you got wrong, how you did, and use that to inform your later exercises and see if you can do better, right? Even before you retake it. So make use of that information.